Okay, children. So today I'm going to talk about a very important concept in relation to bilateral symmetry and rotational symmetry. Now you know that when you take this, you know that this is a rectangle. In this rectangle, here I have traced this rectangle in the board, right? So I'm going to check whether this figure has bilateral symmetry and rotational symmetry. So here I am going to fold this figure like this. So when I fold this figure like this, you can understand that here the two sides coincide with each other. This side and this side coincides with each other. That means this rectangle is having bilateral symmetry, and this middle folded line we call it as the axis of symmetry, right? Then when we fold it in the other way like this, now you can understand once again this also coincides with each other. These two sides coincides with each other. So when we unfold it, you can see this folded line, and it is also another axis of symmetry of this rectangle. So altogether there are two axes of symmetry in a rectangle. So by the way, in this intersection point of these two axes of symmetry, we can take that this point is the center of rotation. That is to find the rotational symmetry, right? Whether this has rotational symmetry. So to find whether this figure has rotational symmetry, what we are going to do is, so here I have traced this figure. I am going to keep this on this, and I have to mark two stars like this on this figure in the board and the same place of the figure in my hand, right? That is for the easiness of us. And then I am going to keep it here on this, and I am going to fix it from the center of rotation which we have found. And then I am going to rotate. So when I rotate, it will be like this. And in this position, you can understand again that these two are coinciding. The figure in the board and the figure we have taken by an A4 paper, you can see both are coinciding. So one time it has coincided, and again we are rotating, and again in this position, when it completes one single rotation, when it completes the first rotation, you can understand again it's coinciding. That means within the first rotation it has coincided for two times, right? So when these two stars come to the same position, we can understand that one complete rotation has taken place, right? So now you can understand that this has been coincide with the figure on the board for two times within the first complete rotation. Therefore, as this figure coincides with its original figure for two times, we call that rectangle is having the rotational symmetry. And as it is coincided for two times, we call that the order of rotational symmetry is 2, right? So this has bilateral symmetry and the rotational symmetry as well, right? So axis of symmetry is 2, this one and this one, and the order of rotational symmetry is 2, as I have explained now, right? Okay. Now, when I take this one, you can see that this is a parallelogram, right? So when I try to fold it, actually I will not be able to fold it out in such a way the two sides coincide with each other. I will not be able to fold it. See, you can see that it will not coincide in this direction, or else when we fold it in this direction also it will not coincide. You can see, right? So this figure do not have bilateral symmetry because it cannot be folded in such a way the two sides coincide with each other, right? But we can find whether it has rotational symmetry. See, I have traced this figure. Once again, what am I going to do is, I'm going to mark a star mark here and here, and when I'm rotating it by fixing it from its center of rotation, right? Then, so you can see when it is coming to this position, you can see it coincides with the figure on the board, and again I'm rotating, and now you can see that the star has come to its original place. So one rotation has been completed, and in this case you can understand within the first rotation it has coincided with the figure on the board for 2 times. That means once again this parallelogram is also having rotational symmetry, right? And also the order of rotational symmetry of a parallelogram is 2. But does it has bilateral symmetry? No, right? That means even though this parallelogram has rotational symmetry, it do not have bilateral symmetry. That is a very, very important thing. When you consider the rectangle, it has bilateral symmetry and the rotational symmetry both. But when you consider the parallelogram, this parallelogram, it do not have bilateral symmetry, but it has rotational symmetry, right? So there can be plane figures which have rotational symmetry but do not have bilateral symmetry. But all the figures that are having bilateral symmetry also have rotational symmetry. That is a very, very important point that you have to know.